Good morning, students. In today's class, we are going to discuss about Pandas, Numpy, and SciPy libraries. So we'll try to cover Pandas and Numpy today. So first of all, we should know that why we need these Python library. Actually, when as you all know that whenever we are working on any machine learning algorithm, we need data sets. Okay, we are working on the data set whenever we are working on any machine learning algorithm. Now, we cannot give directly data to the model because data can be a raw data which model cannot handle or maybe will not get the proper accuracy. So we have to do pre-processing of the data. We have to make the data in such a way that model can accept the data and we can get the better result from the data. So whenever we want to do any type of pre-processing on the data, we need libraries which is Pandas, NumPy and SciPy library. So these libraries are very helpful to analyze, understand and manipulate the data the way users want to give to the model. Okay, so we need to learn these library. So in today's class, we are going to discuss first what is Pandas. So we know that Panda is a one kind of data structure. It's like how you are having array, linked list, all these data structure available. The same way Panda is also one data structure which is support one dimensional array as well as two-dimensional array. And the use of Panda is we can use Pandas for analyzing, cleaning, and exploring and manipulating the data. So if you have some null values in your data set and you want to clean, you can apply Pandas into it. You want to explore your data, you want to understand the data, you can apply Panda. You want to convert data from one form to another form, then again you can apply Pandas. So there are multiple reasons why we should use Pandas on our data set. Now, whenever we are talking about Panda, Panda is able to handle three type of data structure. One is series data structure, another one is data frame, and third one is panel. Panel is discontinued actually. Now, current versions, panels are not available. So we are working only with the series and the data frame. So when we are talking about series are nothing but your one dimension structure is structure of the data is called series, and its size can be immutable. The value of values are mutable, okay, and it will have a label like array. Your array is having index as well as the value. Same way series also having the label and their corresponding value. If I'm talking about data frame size is mutable, values are also mutable, okay, and it is consisting of heterogeneous data structure. As we all know that what is heterogeneous? Heterogeneous means it can handle the different type of data in a single array. And it is two dimensional. The dimension of this data frame could be two dimension. It can have rows and columns. So we can handle series as well as data frame. So if I want to include the library in the Panda, we have to import Panda as PD. So you can write any name here. Just we are writing the alias of Pandas, which is PD here. You can write any alias of it, and it is showing that which version we are using of Panda. It is 1.0.5 version currently we are having. Okay. Now we are talking about the series data. Series is nothing but, as I told you, it is a one day like structure with the label. So this is my data and this is my index, or which is also called label, and in this example it is consisting of integers. So this series is consisting of data and their corresponding label. Suppose I want to know what is the value at index 4. So I will go to index 4 and I'll get the result which is 65. So this is your series. Okay, so this is another example of series. I want to print a series, so I'm writing using pandas. So I'm writing import pandas as PD, and I'm using a functionality of series. So I'm using here pd.series, and I'm writing some values in the form of list. And you will print p, you will get the result with their corresponding indexing, or we can say label. And data type is this integer type. Clear? So this is my series concept. I hope it is clear to you. Now the same series I want in a float type. Okay, this is my integer type and I want data into a float type. Just I have to mention data type. It should be float. So everything, every value is converted into float and it's giving the data type which is also float. So it's easy to convert any data from integer to float. Just you have to mention data type. It should be float. Now I want to perform some operation on this. I want to perform I want to print the axis, shape and dimension of that. So just it will give me the result. The axis is what? It start from 0. Okay, it start from 0. Your indexing is start from 0 and it stop at 10, and I'm getting a step. That your labeling or your indexing is having one step, like 0, 1, 2, 3. There is a difference of 1, so step value equal to 1. What is the shape of my series? Shape of series is what? We know that it is a one dimension array, so we'll be having 10 rows and definitely we'll have only one column. So the shape is like this, 10 comma. Okay. And now dimension I want to know, so it is a one dimension, that's why it's printing 1. So this is all about series. Okay. Now if I'm talking about the data frames is a two-dimensional tabular kind of structure is called data frame. If I'm having data into a tabular form or in the form of row and column, we'll call it as data frame, and it is a heterogeneous data which consisting of row as well as column, and column could be of different type. So that's why we are saying it is a heterogeneous. So if I want to define a data frame, I'll use here pandas, or you can write PD also, PD.data frame. Data, I'm writing none. These are the some parameters which I can pass here: data, index, data type, and column. So we'll move further, then you'll understand what we can keep here. So this is one of the example. We are writing P equal to PD.data frame. We are creating one data frame with suit these values 34, 12, and 23. So when I'm printing P, so it's giving me the result. When I'm printing P, print P dot shape and print P dot access and print P dot data type, it is giving me the result. So it's giving me the result at 0 index, I'm having 32, 34, at 1 index, I'm having 12, at 2 index, I'm having 23. And what is the shape of my data set? My shape of my data set is 3, comma 1, 3 rows, and I have 1 column. So this is my shape, and if I want to print the access is what? It start from 0, it end at 3 because we have 3 rows, and step size is what? 1, because the difference between the indexing is 1. Okay, and the range index is also same, start with 0, stop equal to 1, and step size is 1. Data type is it is integer type. So this is my data frame. Clear? Now we'll take another example. So we have another data frame which is consisting of heterogeneous data. I have integer, I have float, and I have string also. So I have one list which is consisting this, another list which is consisting this. Okay, so when I'm printing the result, it's giving me the result like 56. It's giving me the result, all the values I'm getting here: 56, 23.4, 123, and guava. And the same way I'm having result 34, 12, 14, 40.5, and apple. I'm getting these results, and my result in the shape of what? 4 rows, and I'm having 1 column. So I'm getting the result in this way. So this is all about the data frame. Now we'll open a Jupyter file and we'll try to do some of the basic programming using the Jupyter library. So as we discussed earlier that about the pandas. So first of all, whenever we are working up on the pandas, we have to create a series or we have to create a data frame of it, and then we can perform whatever operation we want to perform on the particular data frame or a series. So in a current program, what we are trying to do, we are trying to calculate the mean salary of the employee. Okay, so I'm creating a data frame, and where there is one column which is salary column, and I want to find the average salary of a employee. So this is my program, and I want to do this with the pandas. So first of all, what I have to do, I'm creating a data. My data set is consisting a dictionary which is having name, age, and salary. Columns are three things are I'm having. I want name, age, and salary of the employee. Name of the employee is Alice, Bob, and Charlie, and David. Age is written here, and salary is this. So I'm having key value pair here. Okay, so with this data, I want to convert this data into the data frame. So simple way of doing this is just I have to do pd.data frame, and I have to pass this variable here. So this is converted into data frame. Now I want to display the data frame. So I want to display the data frame. So just I mentioned print the data frame. So values are available in what? DF it is written. So it's printed. So you can see here every data is converted into a matrix form in the form of row and column. So you can see here you have name, age, and salary, which is my column name, and we have indexing 0, 1, 2, 3, and these are the values corresponding to that. Now I want to calculate the mean salary. So we have a simple formula to calculate mean of salary. I want to calculate the mean of salary column. So I write here df of salary column dot. I want to find mean, so I'm calling the mean function, and I'm storing the result into mean underscore salary variable, and finally I'm printing that salary. So I'm getting the mean salary, which is 65,000. So once I got this, now what I want to do, I want to filter data for individual which is older than or elder than 30. So what I'm doing, just I want to print the employees detail whose age is greater than 30. So just I'm using here df of age should be greater than 30. So I'm printing those values. So it is showing, see here, it was having how many values we were having? Four values we were having. So it will print the results of Alice, it will print the result of Charlie and the David. So we are getting the same results. Sorry, Alice it will not print because age is 25. So it will print the result of Charlie and David 35 and 30. So we are getting 35 and 40. We are getting 35 and 40 here. And these are my results. So this is a basic operation which we are performing on the Pandas. So like this, you can perform multiple operations using the Pandas. So practice different examples and try to explore Pandas in depth. So it will be helpful for you to do the preprocessing. So this is all about the Pandas. Now we are going to discuss about the Numpy. So Numpy is again a library, Python library or a numerical Python library, which is a fundamental package for scientific computing in the Python, and it also provides the support for arrays, matrices, and large collection of mathematical functions to operate on these data structures. So with the help of NumPy, we can manipulate the data into a different way. So we can work on the arrays, we can work on the matrices with the help of NumPy. We'll take a simple example and we'll try to understand that how NumPy works. So first of all, you have to import the library in your program. So I'm importing NumPy as NP. So NP is alias of NumPy. So I'm using NP here. So I'm trying to create a simple array through NumPy. So I'm using here np.array. Okay. And I'm writing this 1, 2, 3, 4, 5. So this is one dimensional array I'm trying to create and I want to print that. You can see here it's created a one dimensional array. Okay, so this is a simple way of creating an array rather than creating using C or C++. It's easy to create array in Python using NumPy. The same way, if I want to create array of 2D, so just I'll use two lists. This is my first list, so this is my another list. This will represent my first row and this will represent my second row, and outer box is representing this is again a form of array. So I want to print this. You can see it has created two-dimensional array structure. Now, the next example we are taking that I want to create an array of zeros and I want to give the length of the array, or we can say dimension of the array. So I am giving it should have two rows and three columns, and I am creating an array NumPy array with zeros, and I want to print that. So it is going to print the values which is consisting all zeros. Same way, I want to create an array with all ones. So I'm writing here np.ones with 3 rows and 4 columns. So you can see here it is created 3 rows and 4 columns array which is consisting of all 1. The same way, I want to perform another operation like create an array with a range of values. So I want to create an array which should be in the range of 10. It means it should be between 0 to 9 it will take actually. So when you will take np dot range, so it will call the range function and it will give a value between the 0 to 9 because I've given range 10. So you can see here it has given the range array with 0 to 9. Same way, you want to create an array with some random values and you want to specify that what should be the size of the array. So you will just call a function with an np.random and you want to create a random array here. So of size 2 of 2. So it is creating a random array with some values. So you can see here it has created an array of 2 cross 2 with some values, and because we have called random function, so that's why the values are random here. So clear how we are going to do this? So this is a basic operation which we are performing using NumPy. We have created here one dimensional array, two dimensional array, array with zeros, arrays with ones. If I want to array in a particular range, we have created, and the same way if I want to create array with random values we can create with NumPy. So this is a basic operation which we have performed using NumPy. Now we'll take another program and we'll try to understand more in more depth about the NumPy. So what we are trying to do, we are trying in this example, we are creating a NumPy array, and this array should have values 1, 2, 3, 4, 5. After that, I'm calculating the mean of the values using mean function. Then I'm calculating the standard deviation using standard deviation function, and finally I'm trying to reshape the array into 5 cross 1. Fine. So now you can see there, what first task is what I want to create an array with 1, 2, 3, 4, 5. So I am creating array using NumPy. So np, I have imported first library as usual. Now I have done np.array and I am writing the value which I have mentioned in the example, which is 1, 2, 3, 4, 5. Now I want to calculate the mean. So simple formula for mean is what? I'll call the mean function and I'll pass this array into it, and it will calculate mean value, and that mean I'm printing here. So my mean is 3.0. Now I want to calculate the standard deviation. So if I want to calculate the standard deviation, so simple formula, no need to write anything. Just you have to write np.std and you have to pass that array which you want to calculate the standard deviation. So I calculate the standard deviation and I want to display the result. So my standard deviation is 1.41 for this particular example. Now I want to perform reshape on my array. I want 5 rows and 1 column. Earlier it was one dimensional array. Now I want to convert the same array into 5 rows and 1 column. So I have converted into it. I just call the reshape function with the dimension 5 comma 1. So you can see here the results are what? It has converted into 5 rows and a single column. So this is my reshape function. Clear? Now, there are some other examples are there. Suppose I want to perform indexing and slicing on my data. So I want to perform indexing and slicing means what? I have an array of some values. I have an array with 1, 2, 3, 4, 5, and I want to do slicing of that. What I want to access the values at second row and third column. So I'm mentioning here second row and third column. Second row means what? Indexing will be 1. And third column indexing will be what? 2. Because indexing will always start from 0. So that's why we have mentioned here 1 comma 2. So it will give the value of second, it will allow me to access the element which is present at second row and third column. So what is my value at second row and third column? The value is 6. Okay, and the same way, if I want to perform slicing, as you all know that how I can perform this slicing. So slicing we can perform very easily using the slicing function. So if I want all rows, so just I mentioned column, and I want only a second column, so I have to mention the column name which is 1. So I write this. So if you want all rows and all column, you will write column comma column. You want all rows but a single column, you will write here column name. If you want here also specific second column to fourth column, so you mention second to fourth. In that way, you can do the changes and you can get the results. Okay. So this is about slicing of your array. After slicing, we'll get the result which is 2 to 5 because I have sliced. I want all the rows of second column, so we'll get the result this. Clear? So I hope it is clear to you that how the functions which we are applying on NumPy is working for us. I will take another example, which is representing the matrix operations using the NumPy. So see here, whenever I want to perform matrix operation, I need two matrices. I have a matrix A, which is consisting of with values 1, 2, and 3, 4. I have another matrix B, which is consisting of result 5, 6, and 7, 8. And if I want to perform matrix addition, a simple formula we need to write which is C equal to A plus B, and it will give me the result which is I have to print the result of C. So you can see here I got the result 6, 8 and 10, 12. 6, 8 and 10, 12 you got when you perform the addition of these two matrices. Same way you want to perform multiplication, just you have to write what np dot matrix function, so it will perform the multiplication of that. Same way, if you want to find the eigenvalues or eigenvectors of any matrix, a simple formula we are using here, np.lin alg.eigenvector of A I want to find out, so just I'm calling that and I'm printing the eigenvalues, at the same time I'm printing eigenvectors of that. So it will give me the eigenvalue of A as well as eigenvector of A. Okay, so because they passed their array, so it's giving me the result of the thing. So this is all about the pandas and numpy. So if you want to be good in the pandas and numpy, so please take some more example and try to learn pandas and numpy in more detailed way so that you can perform any type of preprocessing on your data set. I hope it is clear to you. Thank you.